let's talk about the t-test and the non-parametric test corresponding to t-test. So the t-test is very famous, the one in the statistics and also in the other fields. So t-test is the basics for in the hypothesis testing. So we're going to talk about the theory of on t-test and how to do t-test by using SAS. So today's lectures, we will analyze the same dataset HS grade as lecture 2, which contains the observation in the CSV file, and then this dataset is in the Blackboard. So let's look at the t-test. So some of you may already know about the t-test, but I will talk about the t-test today. First, t-test is the any statistical hypothesis test in which the test statistic follows the student's t distribution if the null hypothesis is true. So the student t distribution is the one of the important distribution and in the statistics. So the t distribution is derived by this. So suppose we have x1 through xn are independently random samples from the normal distribution with mean, mu, and variance sigma square, which means that x1 to xn they are the random samples, and they are, independent and identically distributed. Independent means that they are statistically independent, and they have the same distribution. That's the identically distributed means. So we have defined the sample mean as x bar n, and the sample variance should be Sn square, which you already know about. And then student's t statistic is defined as, for one sample case, is t is equal to x bar n minus mu divided by Sn divided by square root n. It follows the t distribution with n minus 1 degrees of freedom. And when degrees of freedom goes infinity, this t distribution approaches the normal distribution, or t distribution is very similar to the normal distribution when degrees of freedom goes infinity. And when degrees of freedom is greater or equal to 30, we can use the normal distribution to approximate the t distribution. So when you look at this theoretical distribution, so when degrees of freedom is 1, you have a large tail probability on both sides, but if the degrees of freedom increases, your tail probability goes almost 0, which is very similar to the normal distribution. So to test whether the mean of the normal distributed population has value specified in null hypothesis, in that's the case, we use the one sample t-test, so which means that we have one population, and then we are going to test whether the population mean is equal to specific value. And two sample paired t-test is when you have two responses, and if they are from same statistical unit. For example, if you measure say mean of the blood pressure before you give the treatment, and then after you give the treatment, so you are dealing with the same people, so you have the repeated measure for the same people. So in that's the case, we use the two sample paired group t-test, and then we to do the two sample independent group t-test for here. So it's gonna be when you have the two different populations. I mean, for example, population based on men, population based on women. And then if you want to test, in this case, mean of male and female students' weights and UTEP. So in this case, population for male and population for female, they are different. So in this case, we use a two-sample independent group t-test, which means that we are going to test means of two independently normally distributed populations are equal. And then now let's look at the one sample t-test. So we test the null hypothesis that the population mean is equal to specified value of mu0. And then the one uses the statistic, as we talked before, x bar minus mu0 divided by s divided by square root n. Here, this t statistic follows the t distribution when null hypothesis is true. So degrees of freedom is n minus 1. So we have assumptions on here. So we have assumptions that x1 to xn, they must be sampled from normally distributed population and they are independent. And then the reason the t-test is very useful is so when the sample size increases, sampling distribution mean approaches normal distribution, regardless of the shape of the original population. So if you don't know the distribution, population distribution, it is unknown if the sample size decrease, the distribution of sample mean approaches normal distribution, which is the important theorem in the statistics called center limit theorem. So when the sample size is large, one sample t-test is valid for any distribution. So even though your population distribution is skewed, I mean, if you have enough sample size, then you can use a t-test on here. So that is why the t-test is widely used. So here, let's do a test whether the mean of the value of right is equal to 50. So in this case, the SAS program, we use the proc t-test, data equal to HS grade. And here we specify the null hypothesis, the H0 equal to 50. And we set the variable equal to right. So this option, H0 equal to 50, is the null hypothesis testing whether the mean of variable is right is 50. So this VAR means that we only do for right, and if you do not specify it, then the SAS will perform t-test for all numerical variables. So this is the summary statistic and test statistic. So if you run the t-test, you have summary statistic and test statistic. So we have the three parts on here. So A is the number of the non-missing observations, which is the sample size. Mean is the mean of the variable. So we know that the mean of right is the 52.775. Standard deviation is the standard deviation of the variable. And the standard error is this is the estimated standard deviation of the sample mean. So standard error is the S standard deviation divided by square root of n, which is the, you can easily derive from the formula of the variance of the sample mean. And this provides a measure of variability of sample mean. So if this standard error is large, then the sample mean of the sample mean's variability is large. And then we have minimum and maximum of the variable. And then we still have mean on here, and we have 95% confidence interval of the mean. So which is the lower and upper bound of the confidence interval for the mean, which is computed by x bar plus minus t 1 minus alpha divided by 2 n minus 1 s divided by square root of n, which is this t value is the percentile of the 100% times 1 minus alpha divided by 2 and degree of freedom n minus 1. So you can find this t value in statistics books, or you can find numerically by using this software. And then this interval is the mean that we have 95% confident that the sample mean is between 51.45 and 54.1. And then, so this next one is the confidence interval for standard deviation. So standard deviation is based on this formula. So if you remember the statistics theory, n minus 1 times sample variance divided by population variance follows the chi-square distribution with n minus 1 degrees of freedom. So based on that, the confidence interval would be n minus 1 times s squared divided by chi-square value with the 1 minus alpha divided by 2 times 100% with the n minus 1 degrees of freedom. And the upper bound is n minus 1 times s squared divided by chi-square alpha divided by 2 and n minus 1 degrees of freedom. So here in the interpretation is that your standard deviation, population standard deviation, you are 95% confident that is between 8.63 and 10.51. Okay, and then the test statistics. Now, before I talk about part C, so I want to talk about t statistic and p-value. So SAS calculates the t statistic and its p-value. So p-value is the, if you remember the statistic theory, it is the probability that you found the test statistic as extreme as the observed statistic. So if your p-value is very small, then you reject the null hypothesis, which means that there's evidence that mean is different from the hypothesized value. If p-value is greater than 0.05, then you do not reject the null hypothesis, which means that mean is not different from the value in your hypothesis. So in C, so you have the degree of freedom 199 because this is the n minus 1 degrees of freedom. And t value is the test statistics, so x bar minus mu 0, minus 50 divided by s divided by square root n. And this third part is the p value, which is the less than 0.0001, which means that we reject the null hypothesis in here. So right is smaller than the 0.05, so which means that we conclude that meaningful right is significantly different from 50. So that's our conclusion. So now let's talk about the paired group t-test. So we have the paired group t-test, which means that when you have the two measures, and then if you want to test the difference between the two measures, and then these two measures are measured from the same unit, and then if you want to compare the difference between the two measures, for example, the blood pressure, mean of blood pressure before the treatment and after treatment, then we use the paired group t-test. So this paired group t-test is so null hypothesis is mu1 is equal to mu2. So mu1 is the mean of the blood pressure before the treatment, and mu2 is the mean of blood pressure after the treatment. And then one can use statistic x bar minus d X bar D, which is that the average of differences between two matched samples. SD is the estimated standard deviation of all the differences. So this X bar D is computed by you take a difference between two measures and then take a mean. Then this SD is computed that you take a difference between two measures and then you compute the standard deviation of the difference of the two measures. This constant mu0 is going to be 0 or non-zero. And degrees of freedom is still n-1. So this is still that if null hypothesis true, this T statistic follows the T distribution with n-1 degrees of freedom. So paired t-test is used in the before-after studies or when the samples are the matched pairs or the case in a control study. So for example, you want to, you know that the same students took both writing and reading test, and then you want to know relationship between the two scores in each student. So then you can use a paired group t-test for in this case. So the assumptions are, so only matched pair can be used. If you have different number of observations on these measures, then you cannot do this pair t-test. And then the variance of two samples are equal. The observations must be independent of each other, which means that your two measurements, they are correlated, but the one unit and then a different unit. So if we have a person A and person B, the scores from the person A should be independent from the scores from the person B. And also the data should be from normal distribution or the sample size large. Then for the proc t-test instance, you can use this paired statement with the two measures, write, start, and read on here. Here we like to use paired group t-test to test population means of the writing score and reading score. So we use a write, start, and read. And the SAS output is that. So we take a difference of the write and read. So basically, we treat write and minus read as the one variable, and then we apply the one step t-test on this difference. So you can see that the difference is mean at 0.54, standard error is the 0.63, and you get the 90% constant limit of the mean. So here the mean is the mean of these differences, and the standard deviation is the standard deviation of these differences on here. And then this t value is the small, and then this p value is the greater than 0.05. So you do not reject the null hypothesis. It means that there's no difference between write score and reading score, which means that means for the write and read are not statistically significantly different from one another. Okay, so yeah, I will talk about the independent group t-test in the next video.